There are roughly 900,000 miles of telecommunication cables on the sea floor. These cables cover every ocean on the planet, and they're responsible for the transfer of about 99% of all digital data. Undersea cables are not new. They've actually been used since the 1850s when they were initially used to carry telegrams. Also known as submarine communication cables, they are fibre optic cables that have been laid on the ocean floor. The optic cables carry information between two places using entirely optical technology. Optical meaning light-based. A fibre optic cable is made up of incredibly thin strands of glass or plastic. These are known as optical fibres. A laser converts electrical information from a device into a series of light pulses. The pulses are then fired down the fibre optic cable, where they travel and emerge at the other end. Laser light is used in fibre optic communications because it is a single wavelength, which means it's ideal for long-distance communications. So, with undersea cables, lasers on one end of the cable fire at extremely rapid rates and thin glass fibres to receptors at the other end of the cable. Every time you send an email or browse a website, the data is travelling through these communication cables. Lasers are transmitting your data right now. But how did the cables get there? The cables are laid by slow-moving ships. As the ship moves, the cable is unspooled and carefully placed on the ocean floor. Sometimes the cable is buried in the seabed sediments in shallow waters to protect it from things like fishing activities and anchors. In deeper areas, the cables are usually laid directly on the seabed. But they don't work alone. Long optical cables require periodic signal boosting. For this, they need what we call repeaters. Can I repeat that? Yes, I can. A cable is typically as wide as a garden hose, but the filaments that carry light signals are extremely thin. Each fibre is 10 times thinner than a single human hair. Because the light signal loses strength en route, the repeaters are required at regular intervals to restore it. So repeaters are usually installed around every 50 to 80 kilometers, and they use optical amplifying technology to boost the signal. So they receive the weakened optical signal, run it through a semiconductor amplifier, and convert it back to light. Just one of these cables supports millions of netizens at the same time without slowing anyone down. So they're pretty important, which means they're also protected in several ways. First of all, the cables aren't just placed randomly. They follow strategic routes to avoid known hazards and areas of geopolitical tension. Secondly, they're made of extremely tough materials, including steel armour, to withstand harsh ocean conditions and accidental impacts. Even so, every year around 100 to 150 undersea cables do get accidentally cut. But most nations don't rely on a single cable. They have more cables and more bandwidth within those cables than the minimum required amount. So if any of them do get damaged, others can take over. This video was brought to you by Undersea Cable.